Well, hello radio fans, this is Peter on the radio bench. Today we're looking at a meter calibrator, an ammeter calibrator that I made up for 10 amp meters. This particular one used a meter that I had hanging around that actually was cracked. I was going to use it in the ham radio Class E transmitter. And never got it had a crack in it, and I finally found a use for it. So what it basically does is I use it to calibrate some meters I use in some equipment, radios and equipment that typically use 10 amp meters. So here's the schematic here. Basically it uses two double pole, double throw switches. See, what we're doing here is we're actually the switches so you can switch phases. So you can actually look at two lines or two DC feeds. In this case, this was for the two phases of the push-pull Class E RF deck. So, and there's the meter there. Showing the meter and the adjusting pot that I use these in most of my meters. And of course that actually is the case here in the calibrator too. So what you do is you break out the shunt and you take a 100 ohm pot and you put it across the meter. So it gives you an ability to adjust the currents. So it works pretty good. So and this here is I think it's around 100 watt 5 ohm resistor, and let's go ahead and fire up go ahead and put some 12 volt power to it. You can see there that actually is correct, that meter. And this one here is now correct, and what I do is I can adjust the pot here accordingly. I found that the best calibrating pot is a multi-turn pot, not just a single turn pot, because this gives you much better calibrating accuracy. So there you go. I use that to calibrate all the meters. It works very, very well. I'll go ahead and shut this off. I'll show the back side of it. Kind of a bit of a rat's nest. So here's the multi-turn pot here. There's the shunt, which we broke out, and of course the connections. I use the Anderson power pole connections. They're really, really useful. They're good for 30 amps. I use them on all kinds of stuff. They're really, really great. So now let's take a walk over to the Class E transmitter station, which is right here, and getting by these microphones. If you look down in there, you can see there's a Anderson power pole right there, and that's using the DC feed into the RF deck. So now notice that I've got the phases, I've got the red and black kind of mixed up, but that really didn't matter. It didn't particularly play a role, so I didn't care. So I use that to adjust the meters here. These are the phases, each phase here. So that kind of shows how that goes. I'm going to try to grab the other hand and hold this and hopefully not shake too much, and then we'll fire up the transmitter. This is N1PS testing on 75 meters. And there you go. So I had found that the meters had drifted some, and I had to recalibrate them. So that was why I made the meter calibrator unit, and which did work very well. These I was doing some testing on the efficiency of the transmitter, And I didn't believe the ammeters anymore. Something doesn't seem to be right, because I had one phase showing different current than the other, and that didn't seem right. And sure enough, the meters were off, and so that worked out great. I also did that in my solar controller too. That worked out very well, because again, I noticed that the solar controller meter, which also was a 10-amp meter, had drifted some, so that all worked well. All worked well there. This is the RF deck for the Class E transmitter. It's got 12 chips in it. There's already a video that describes the building of it. I recently just added the voltmeter in there, which turned out to be really, really useful. So basically, if we get over here and fire, as the push talk switch there, and fire it up. There you go. So it has 32.5 volts DC feeding the RF deck at 10 amps. So it's got a power input of 325 watts, and it's got a and I think for the actual RF output, it's about 260 watts, somewhere around there. That's another homemade meter there. So homemade RF meter. So there you go. That's a story from here.